Здравствуйте! Today is the 22nd of July, 2025. As we mark this moment in time, humanity stands on the edge of remarkable discoveries, peering deeper into the universe than ever before. When we look up at the night sky, we see a sea of stars, each one a sun, many with their own planets, is a breathtaking reminder of how vast and mysterious our universe truly is. The universe is teeming with billions of worlds, and scientists are on a thrilling hunt for the absolute smallest among them. These tiny planets, often overlooked, may hold secrets about the origins of life and the diversity of planetary systems. Imagine being a cosmic explorer, using telescopes to spot tiny planets light years away, an immense challenge, like finding a firefly next to a searchlight from hundreds of kilometers away. The task requires patience, precision, and a bit of cosmic luck. Astronomers have become cosmic detectives, searching for the faintest clues that a world, perhaps no bigger than our moon, orbits a distant star. They sift through mountains of data, looking for subtle signals that reveal the presence of these elusive worlds. This hunt isn't just about finding the tiniest planet. It's about understanding how planets form and whether small rocky worlds like Earth are common. Each new discovery challenges our theories and expands our imagination. Each discovery helps us piece together the grand puzzle of planetary systems and our place in the cosmos. The more we learn, the more we realize how much there is still to uncover. So, let's dive in, exploring the technology, the discoveries, and why these tiny worlds matter. The journey promises wonder, challenge, and perhaps even a glimpse of our own cosmic origins. Are you ready? Let's talk. How do scientists find these tiny distant exoplanets hidden among the countless stars in our galaxy? They're far too faint and small to see directly, even with our most powerful telescopes, so astronomers have to rely on clever, indirect methods to reveal their presence. The most successful is the transit method. When a planet passes in front of its star, it blocks a tiny fraction of the star's light, causing a brief, subtle dip in brightness that astronomers can detect. Space telescopes like Kepler and TESS keep a constant watch on hundreds of thousands of stars, searching for these periodic, telltale dips in light that signal a planet's passage. When astronomers see multiple regular dips in a star's brightness, it's a strong sign that a planet is orbiting there. The depth of each dip even reveals the planet's size, giving us clues about its nature. Another powerful technique is the radial velocity, or Doppler wobble method. Here, astronomers detect the star's subtle back-and-forth motion, caused by the gravitational tug of an orbiting planet. As the star wobbles, its light shifts between blue and red, a cosmic fingerprint that lets astronomers estimate the planet's mass and even its orbit. These methods demand painstaking data analysis, careful filtering of noise, and follow-up observations to confirm each discovery. Together, these techniques have opened a window to a universe teeming with hidden worlds, each with its own story. It's a cosmic dance, and with each new discovery, we're learning to read the steps and understand our place in the universe. The hunt for tiny planets is a triumph of human ingenuity, creativity, and persistence. Now, let's meet the smallest exoplanet discovered so far, a true gem among the stars. Meet Kepler 37b, the smallest exoplanet discovered to date. It orbits a star about 210 light-years away in the constellation Lyra, part of a system with at least 3 planets. Kepler 37b's discovery in 2013 was a breakthrough. It's smaller than any planet in our solar system, even tinier than Mercury. Its diameter is about 3,165 kilometers, just a bit larger than our moon. Imagine a whole planet, barely bigger than our satellite, orbiting a distant sun. Kepler 37b orbits extremely close to its star, completing a year in just 13 Earth days. This proximity makes it brutally hot. Surface temperatures reach around 425 degrees Celsius. It's a scorched, barren world, utterly inhospitable, but its discovery shattered our assumptions about how small planets can be. Kepler 37b opened a new category of sub-Earth worlds. Let's put its size into perspective. Kepler 37b is a true cosmic dwarf, smaller than Mercury, just a bit bigger than the Moon. Earth's diameter is about 12,742 kilometers. Mercury's is 4,080 kilometers. Kepler 37b's is only 3,165 kilometers. Detecting such a tiny planet was a huge technical feat. The dip in starlight it causes is just a few parts per million. Only the Kepler telescope's sensitivity and the star's stability made this possible. Kepler 37b is almost certainly rocky, but calling it Earth-like would be a stretch. Its close orbit means one side faces perpetual scorching daylight, the other eternal darkness. The surface is likely a desolate, baked landscape. No water, no atmosphere, no life. This discovery challenges our models. How can such a small world form so close to its star? Kepler 37b forces us to rethink what's possible in planet formation. Science advances with every surprise. Why search for tiny, inhospitable worlds like Kepler 37b? These discoveries are crucial for planetary demographics, understanding what kinds of planets exist and how common they are. Before Kepler, we mostly found giant, hot Jupiters because they were easiest to detect. Kepler 37b proved that much smaller planets exist, correcting our bias and expanding our view of planetary diversity. Each small planet helps refine our theories of planet formation. Are we typical or an oddity? The existence of Kepler 37b challenges our models and suggests small, rocky planets might be common. Ultimately, the search for tiny planets is tied to the search for life. If small, rocky worlds are abundant, some may orbit in the habitable zone, where liquid water could exist. Finding the smallest planet is a stepping stone toward finding a second Earth. Every tiny world is a clue in the cosmic puzzle. The transit method made Kepler 37b's discovery possible, but it's a cosmic game of hide-and-seek. Kepler stared at over 150,000 stars, recording their brightness every 30 minutes for years. Scientists sifted through mountains of data, searching for the faintest, periodic dips, a signal in the noise. The planet's orbit must be perfectly aligned with our line of sight, otherwise we miss it. For every planet we find, there are likely hundreds more we can't see due to misalignment. Despite this, the transit method is powerful. It reveals a planet's size, orbit, and, with further study, even its atmosphere. Transmission spectroscopy lets us analyze starlight passing through a planet's atmosphere, searching for water, methane, or oxygen. This is currently possible for larger planets, but new telescopes are pushing these limits. The simple act of watching a star flicker is our best tool for characterizing distant worlds. The search continues, ever deeper. Could Kepler 37b harbor life? The answer is a resounding no. Its surface is over 425 degrees C, hotter than a pizza oven, making liquid water impossible. Any atmosphere would have been stripped away by intense radiation and solar wind. The planet is likely a barren rock, possibly the remnant core of a larger world. One side is scorched in perpetual daylight, the other frozen in endless night. No air, no water, no weather, just brutal extremes. Kepler 37b is not a candidate for life, but a lesson in planetary diversity. It reminds us that not all rocky planets are Earth-like. Even inhospitable worlds teach us about the universe's creativity. Kepler 37b was a milestone, but the search for exoplanets is just beginning. Each new discovery opens up more questions about the universe and our place within it. Missions like TESS are now scanning the entire sky, looking for planets around the nearest, brightest stars. With every pass, TESS is uncovering hundreds of new candidates, expanding our catalog of possible worlds. The James Webb Space Telescope is the next leap. It can analyze exoplanet atmospheres, searching for biosignatures like oxygen and methane. Webb's advanced instruments allow us to peer deeper into space and time, revealing details we could only dream of before. Future ground-based giants, like the Extremely Large Telescope, may even directly image distant worlds. These observatories will help us study planets in unprecedented detail, from their weather patterns to their surface features. The ultimate dream, a telescope powerful enough to photograph an Earth-like planet and study its atmosphere for signs of life. Imagine seeing continents, oceans, and clouds on a distant world and analyzing its air for the chemical fingerprints of biology. NASA's proposed Habitable Worlds Observatory aims to do just that, a true successor to Hubble and Webb. This mission could revolutionize our understanding of habitable planets and the potential for life beyond Earth. These projects will take decades and billions of dollars, but the payoff could be profound. The investment is immense, but so is the potential to transform our view of the cosmos. The journey that began with tiny scorched rocks like Kepler-37b is paving the way to finding a true Earth twin. Each step brings us closer to answering the ultimate question of whether life exists elsewhere. We're on the verge of answering one of humanity's oldest questions. Are we alone? The discoveries we make in the coming years could change our understanding of life itself. The future of exoplanet science is brighter than ever, filled with hope, curiosity, and the promise of incredible discoveries yet to come. What's the takeaway from Kepler-37b's story? We've learned that planet formation is diverse, creating worlds of all sizes and types. The discovery of tiny planets like Kepler-37b shifts our perspective. Our solar system is just one of countless possibilities. Each new world is a lesson in cosmic humility and a testament to human curiosity. We search not for immediate gain, but to understand our place in the universe. Finding the smallest planet is a crucial step toward finding another Earth. Every discovery, no matter how small, expands our horizons and challenges our theories. Kepler-37b may be a tiny scorched rock, but its discovery was a monumental leap for science. The universe is vast, and we've only just begun to explore. Thank you for joining this cosmic journey.